Today we're going to look at multiplying matrices. Now this is a little bit different from adding. It's going to be, some of it's going to be super easy, some of it's going to be a little bit more complicated. But let's take a look. First off, multiplying a matrix by a constant. This is super easy because it's just a giant distributive property. So if I want to multiply a matrix by a constant, say the 2 by 2 matrix here, that is 2, -5, 6, 7. I want to multiply the entire matrix by the value 3. Literally all I'm doing is I'm multiplying 3 onto every number in there. Okay? So that being the case, just because I can't see things right now, pretty easy to do. Okay, we'll just take 3 times 2 is 6. 3 times -5 is -15. 3 times 6 is 18. 3 times 7 is 21. All right, it doesn't get much easier than that to multiply by a constant. So multiplying a matrix by a constant, I don't think that's really going to require any further explanation. I think you can handle that. We will deal with that second half of chapter 4. Multiplying a matrix by a matrix is more complicated. We don't just multiply corresponding elements. It's not like addition. Multiplying two matrices, matrix A and matrix B, is allowed only when the number of columns in A equals the number of rows in B. Okay, let that sink in. Remember, we always name row by column. Okay, so if row by column here for matrix A, so the rows of A and the columns by A, I can only multiply that if the rows in B equal the columns in A. Okay, so those two must be equal in order for us to multiply. My result will have the same number of rows as matrix A and the same number of columns as matrix B. All right, so generally, unless a matrix is square, which means same number of rows and same number of columns, we can't multiply two matrices of the same dimension. Okay, that can't be done. So if I need to multiply two matrices, here I have two square matrices. Now square matrices are nice because they multiply really easy. Because the number of rows and columns is the same all the way around, we don't even worry about that sort of thing. So, if I want to multiply these two matrices, this is a more complicated process. We multiply the first row by the first column to get the result that is in row 1, column 1. Okay? Now, how do we do that? It's actually kind of interesting. We'll take the first number in the first row times the first number in the first column, 1 times 2. You can see this is being done for you down below. So 1 times 2, and then add to that the second number in the first row times the second number in the first column, 0 times -1. So 1 times 2 is 2. 0 times -1 is 0. So 2 plus 0, that's going to give me a 2 in that position. Okay? So that gives me a 2. Let's move on. Let's go for the next element of this multiplication. To get the information in row 1, column 2, I'm going to have to do row 1 times column 2. So again, I'm going to take the first times the first, 1 times -3, plus the second times the second, 0 times 8. So we already know that their first solution here, so filling it in one piece at a time here, it's going to be a square matrix. 1 times 2 was 2. We had plus 0. 1 times -3 is -3. -3 plus 0 times 8. -3 plus 0 is a -3. Okay? Now we move on. Now I say I want what's going to be down here, down the lower left. How am I going to get row 1, or row 2 times row 2, column 1? I'm going to multiply row 2 times column 1. Okay? So in order to get the element that's down here, I'm going to take row 2 times column 1. And again, we're going to multiply the first entry times the first entry, 4 times 2, this right here. And the second entry times the second entry, 5 times -1, that's right there. Now this time we didn't have a 0 in there, so we're actually going to have some numbers to fill in. So as we're filling in and building our result matrix, which is going to be 2 by 2, we already have the 2, we already have the -3. Now 4 times 2 is 8, plus 5 times -1 is -5. 8 minus 5 gives me a 3. Finally, let's do the last one. Let's see what comes in last. In order to do the last one, I'm going to have to do row 1, or row 2 times column 2. So I'm going to erase a little bit here. Hold on. I'm going to erase this just real quick. And again, we're going to do, this time, row 2 times column 2. So when I do that multiplication, again, I'm going to take the first element of the row times the first element of the column. So 4 times -3 plus the second element of a row times the second element of the column, 5 times 8. Well, that's a 40. That's a -12. -12 and 40 is 28. And there's my multiplication. I've just multiplied those two matrices. That is a more complicated process. Okay? Now, again, I can't multiply any two matrices. They have to be the number of columns in the first one equals the number of rows in the second one. So, let's be careful here. This matrix A here, how is the row column configuration here? I have row 1 and row 2. So I have 2 rows by column 1, 1 column. Matrix B here only has 1 row by 2 columns. Matrix C is square, so that's nice. It has 2 rows by 2 columns. We like the square ones. They're easy. So, can I multiply A times B? That'd be a 2 by 1 times a 1 by 2. Well, since times a 1 by 2. Since these inside numbers match, the number of columns in matrix A equals number of rows in matrix B, we can multiply them, and the result will be, using our outer numbers, a 2 by 2 matrix. Okay? Can I multiply A times C? Well, let's see. Matrix A is 2 by 1. Matrix C is 2 by 2. So no, we can't multiply it because those two numbers are not the same. Okay? What if I did CA? Could I multiply C times A? You're saying, well, you couldn't multiply AC. Why could you multiply CA? Because order matters. If you go C first, C is a 2 by 2. And A is a 2 by 1. So C by CA, absolutely, these two do match. So yes, we could multiply them. And the result would be a 2 by 1 matrix. Okay? Could I multiply B and C? Well, B is 1 by 2. C is 2 by 2. The inside numbers match, so yes, we can multiply them. And the result would be a 1 by 2 matrix. Okay? Awesome. Let's practice multiplying. Oh, square ones. Again, I love the square ones. They're easy. First off, it's a 2 by 2 times a 2 by 2. These match, so, and the outer numbers give me a 2 by 2 when we're done. See, squares are so nice. They work that way. So let's go ahead and do our multiplication. Okay? In order to get what comes in row 1, column 1 of my solution, I have to multiply row 1 times column 1. So 1 times 3 is 3. 0 times 4 is negative 4, or is 0. So 3 plus 0 is there, or that's going to be a 3. In order to get row 1, column 2, I'm going to have to multiply row 1 times column 2. 1 times 8 is 8. 0 times 7 is 0. So that gives me an 8. In order to get row 2, column 1, I'm going to have to multiply row 2 times column 1. 0 times 3 is 0. 1 times negative 4 is negative 4. So I get a negative 4. And finally, in order to get row 2, column 2, I'm going to multiply row 2 times column 2. So 0 times 8 is 0. 1 times 7 is 7. And we get a 7. And there's my result matrix. Now you're probably saying, wait a minute. My result matrix is exactly the same as my original matrix B. That's true, because this is what we call an identity matrix. It has 1s on the diagonal and 0s everywhere else. Now, it's not going to be super important to us, but it's an interesting little matrix. It's like multiplying by 1. Multiplying by the identity matrix gives you exactly what you got back, what you started with. Okay? So fun stuff. Let's try one more. Let's multiply one more set of matrices, and I'm going to ask you a couple questions during this. So, my matrix, let me get a skinnier pen here. I'm going to go 2, 1, negative 1, 3 times 4, 1, 5, negative 3, negative 2, 0. Okay? I want to multiply those. The first question is, can I multiply these? Is this even possible? Can I multiply these two matrices? Well, this is a 2 by 2 matrix. It's square. This has how many rows? Row 1, row 2, so it's 2 rows and 3 columns. So yes, the inside numbers match. I will wind up with a 2 by 3 matrix from the outer numbers. Okay, so yes, I can multiply them. Let's go ahead and do it. I'll get us started. Row 1. Sorry, I just circled column 1. Silly me. Row 1 times column 1. Okay, so we're going to take 2 times 4 is 8, plus 1 times negative 3 is negative 3. So, spin my page a little bit here, give myself a little more space. So if that's the case, 8 plus negative 3 is a 5. Now let's do row 1 times column 2. And I'm going to let you tell me what the solution for that is going to be. All right, now that we've done that, let's go to row 1 times column 3. So that would be 2 times 5, which is 10, plus 1 times 0, which is 0. 10 plus 0 is 10. Next, we'll go to row 2, column 1. Negative 1 times that is negative 4. 3 times negative 3 is negative 9. Negative 4 times negative 9 is negative 13. . 2 times column 2. 2 Negative 1 times 1 is negative 1. 3 times negative 2 is negative 6. So plus negative 6, which is the same as minus 6. So negative 1 minus 6 is negative 7. And the last one is going to be yours. See you in class.